Now let us design a simple diode rectifier, half wave diode rectifier. So for that we require a simple diode. So from elements I can select that diode, go to the elements, power, switches, and here it is diode. So just click it and place it in the editor window. After pressing the right click button, the diode can be rotated like this. Press escape. Now if you want to see the closer view of this, click zoom. Now the next element we require is a resistor for as output load. So let us take one resistor and place it here. Then we require a power source. So let us have a sinusoidal input source. So it can be taken from the lower plane here. So this is a sinusoidal source. If I click it, I will get this kind of symbol. Place the symbol here. Now you can adjust the parameters of this source. The name of this source is V1. The voltage is 100 volt, 110 volt. You can change the voltage to say 50 volts, and the frequency is 60 hertz. We can change it to 50 hertz. And if you want to display all these parameters, then just click those values over here. Now these are the values we can get. Now to connect these elements we have to use a wire. So wire is available in the upper plane or it is available in the edit box. So place wire, you can select W, or you can give the command W, or you can choose the symbol wire. So select this, join the two ends of the components. Now if red color is there, then it is the meaning of this is both the ends are joined correctly. In the join next to join resistor and the source. Now we have to use a ground terminal in order to provide ground to the source. So let us choose a ground and just click it over here. Now to measure the current flowing and the voltage across the load, we have to select some voltmeters and ammeter. So again go into the elements menu, go into the others menu, go into the probes, select DC voltmeter, or we can select others probes, voltage probe, that is node to node. Now if I click the mouse at the right button, we can place it in the vertical direction. Now join this to these two branches using wire. Like this. Now we can place, next we can place the ammeter. So go to the others, probes, DC ammeter, and place it over here. Now other probes, to see, we can place probes like this also. A simple voltage probe that can be put at the input side to see what kind of voltage the source is generating. And the other element current probe is also placed in order to see the current at the input side. So now the circuit has been designed. We have to go into the next menu to simulate the circuit, that is simulate menu. So we can first, we will choose the value of the resistors. Let us keep these resistors to say 40 ohms, and the value is R2. So I will show that value into the editor window and close this menu. Now the name of this voltmeter at the output side is VP1. So let us, and this, so a probe is V2. Show it into editor so that we can find which is the input current and which is the output current. So I1 is the input current and ADC1, so it is a DC analog to digital current source. So instead of this, let us use simple probe, that is current probe, and place it here like this. Okay, now next simulate. For this we first will choose the simulation control, choose this block, clock like icon will be generated. Place it somewhere into the editor panel. Then set the time for how much time we want to run this simulation. So it is showing now point not 1 second. That is, the time is actually again. So let us place it for zero point 0.1, and then the time step is 1 into 10 raised to minus 5. So let us run this simulation for 1 second. Close it. After this, you can use F8 button, or you can choose this run simulation. It will go to the sim view menu directly. If some warning is there, just click OK. Now you can select any one parameter to see in the sim view menu. So I will click I1 and I will click V2, that is the input voltage and current. I will add here into the second panel and will click OK. So this is the view of the input voltage V2 and input current I1. Now I1 is very small as compared to V2. So if you want to view larger, so just click I1, drag it in the lower menu. You can multiply I1 by any other constant variable. So for this, some mathematical functions are given in this bar. So choose star button, multiply by say 10, and just add it over here. So this is the second option that is added in the same panel. So click OK. Now it is generating the current at some higher level, that is amplified level. So the current I1 is now greater, so you can view it easily. Now if you want to add another window in the same panel, we can select the output parameters, like VP1 is our output voltage across the load, and I2 was the output current. So add these two values here and select OK. So this is the output of half wave rectifier. This is the first cycle. The second cycle, diode will not conduct, and again in the next cycle, for next positive cycle, diode will conduct. So according to that, the outputs are available. We can use different measures like maximum, minimum on this waveform. So if I select maximum, I can get the maximum values of this V1, I1, V2 and I2 parameters. We can analyze this waveform. I can find different parameters like power factor, which will give us over here, which are available over here. We can find out average power. So we can get average of any waveform, average of X, that is available. So it gives me average value. The numerical value is obtained in this smaller window. We can label the lines. We can put some text, like for example, if I want to put some text like half, or say diode rectifier, then I can choose the font of that. Let us choose the larger fonts and place it over. So in this way, justification can be provided left center, right center, like this, and just place it over here. So this way we can put different text. Dotted line, we can choose the line parameters of any output waveform. Then we can see the FFT of this waveform. So let us find out how FFT works. So if I click perform FFT, then a frequency response is generated. See here, the frequency response has been generated. So there is a peak at some value. We have chosen the frequency which is equal to 50 Hertz. So at 50 Hertz we can get a peak. So let us find out what is the FFT looks like. So there are some DC component and some harmonics are generated for VP1 and for I1 also, I2 also. Similar to that, in the upper side, these two parameters are generated. So in this way, we can obtain the output waveforms and we can generate the different FFT of that waveforms also. We can find out average, we can find out total harmonic distortion, we can edit the graph. Also, we can save this panel as a print to print the output whenever we require. We can save this file. We can reload the data only if you want to see the sim view. We can reload the file after saving. So let us design a AC to DC converter using a thyristor. So I will delete this diode and I will place a thyristor component. So select power, switches and thyristor. Place the thyristor over here. Other things are similar. We have provided a voltage source of 50 volt and a frequency of 50 hertz. So let us change the voltage source because thyristors are generally used for high power applications. So let us make it 100 volts. And current and voltage probes are also available. Let us change the name of this voltage as V1, or you can just select like V in and change the current I2, or let us give the name as IO, the output current. Show it in the output editor and close this. Now to trigger a thyristor, we require a getting signal that is available in the power switches getting block. So use a wire and join these two elements. Okay, now they are joined. Now just click that escape, click this block. This is known as getting block, and the so getting signal is provided, and this signal can be set to same frequency of input. So as we have selected 50 hertz, we can set this as a 50 hertz signal. The number of points are 2. So we can just show it over here. The switching points are 0 to 180 degree. Now if I switch it at 0, then whole cycle is rectified. If I want to trigger it at some another angle, say 20 degree, if I want to provide a getting signal at 20 degree, the getting signal will start at 20 degree and let us end that signal at 30 degree. So a pulse of 10 degrees is provided, and that is there is a dot sign over here, so keep into mind and just close it. Now again the simulation control is available, so close it, this run the simulation. Now see I1, V in, add, these are the input parameters. Then in another menu we can add VP1 and I0. See, after this point the thyristor has been triggered and the output waveform is available. We can find out uh, other parameters. We can add other parameters like I0 multiplied by current multiplied by voltage will give us the power rating. So we'll take the I0, multiply it by VP1 value and add this parameter over here, which is known as power. So the power waveform is shown like this. We can find out total harmonic distortion. Let us find out total harmonic distortion. If the fundamental frequency is 50 hertz, then what is the harmonic distortion that is displayed over here? The value of the harmonic distortion for output current and source. In this way, we can analyze simple AC to DC half wave converter using thyristor. Thank you.